All right, so we're going to take a little bit of time and try to build an encryption utility. We're going to be able to encrypt files, hopefully, and we're going to use Python to do so. So I'm going to go and get started. I'm going to click on my Kali VM. Well, this is coming up. Like I said, we're going to use some libraries that may not be installed. So we're gonna check. We're gonna make sure our Python environment is set up correctly. Go ahead and log in Kali. I mean, what's nice about this program is that hopefully we'll be able to write this program one time, and then as long as we install our project, all of our dependencies appropriately, that is to say, the cryptography library we're going to use, it should work on Windows, Linux, Mac, all these awesome platforms that we use. So first things first, we're going to probably have to consult the internet. So I always like to make sure I have access to Google, and I ping google.com. It looks like I have access to the internet, so that's good. So what do I need to do? How do I even start a project like this? I say I want to create a program that encrypts things. Well, I might need some things to encrypt. Let's try creating some files. I'm going to go into my downloads folder. We've got some things we've worked on from other lessons. Maybe I'm going to create a document, a new document called secret_message.txt. .txt is just a text file. If I double click that text file, it'll open up in Visual Studio Code. That's because we installed Visual Studio Code. If you haven't seen that part, watch that video, install Visual Studio Code, get it set up to write Python code. That's what we're going to do. So what can I do? This is the secret that I want to keep secret. I like candy. That's a secret, I guess. So I'm going to save that. I'm going to close it. Let's see. If you right click in this folder, you can open terminal here. Now I'm in the downloads folder. So it saved me from having to type CD downloads. That's all. So if I look at the stuff or list the stuff in this directory with ls, if I do a long listing, ls tech l, I can see that secret message is exactly 64 bytes long. That's 64 bytes of information. If I put it onto the screen with the cat command, secret message.txt, you can see this is all the text that I put, and it's basically what's inside of Visual Studio Code. All right, so what do I need to do? I said we were going to write a Python program. So let's create a new Python program in Visual Studio Code. If you go to File, New File, and if you go ahead and tell it to save something, just hit Control S. I'm going to call this encrypt.py. Okay, so I did that. You'll notice that I have like a little Python icon here now. Down here it says Python as opposed to plain text. This is pointing at the Python interpreter, so it's already configured to write Python code. First things first, it's never a bad idea just to sort of normalize things. Print, this is the encryption program. I'm going to save that. I'm going to try to run it just to make sure all the parts that I have so far are working. Because I'm in the same folder, I saved it in Home, Kali, Downloads, and it's called encrypt.py. And I happen to be in the Downloads folder here. I can type, what can I do? Python 3, because this is the language we're using, Python 3.9.1 down here. Python 3 encrypt.py. If I hit enter, you can see it says this is the encryption program. So that means we're pointed up, we're looking at all the right things. What do we have to do? How do we go about doing this? First of all, we've got to get access to, we've got to find out what file does somebody want to try to encrypt. Okay, so how do I get that? I can use the input command to ask a question. Real plain, simple thing. So I'm going to file name is input, the result of the function. What file would you like to encrypt? Question mark. All right, so this is going to put something onto the screen, collect whatever somebody types on the keyboard, hits enter. It's going to store that in the variable file name. If I hit print, let's do F strings. F, you are going to try to encrypt, curly brace, file name. There we are. Save. Okay. So if I run this program now, I'm going to come back over to this terminal. Python 3 encrypt.py. This is the encryption program. What file would you like to encrypt? I'm going to say asdf.txt. It says you are going to try to encrypt asdf.txt. Great. We're off to a solid start so far. We need to try to open that file. We need to look at its contents in order to know how to encrypt them. All right, so I'm entirely freestyling this. So let's see, how do we start that process? I'm going to create a function that does it. I'm going to define a function, def encrypt. And it's going to take some data. I don't know what the data is. It could be a picture, hopefully. It could be a zip file. It could be a Word document, something. It's just going to take some data. And then print data. All right, so I'm encrypting data when we call the encrypt function. I'm going to put my encryption function at the very top. I'm going to remove the part that says this is the encryption program because that's not anything important. Move around. Okay. Let's see. So what do I have here so far? I need to file equal file data is assigned the result of the expression, which is open file name. And then this is interesting. I'm going to type, rather than just leaving it as read, by default, if you leave it like this, it's going to open it and it's going to treat it like text. If you tell it to read the binary RB, it's going to return bytes to you. And bytes are generally what we're going to work with when we do encryption. And we're going to use like real like AES 256 encryption. That's my plan anyway. File data. And then not only we're going to open it, but we're going to, let's just open it. File is that. So we've opened it. Now I want file data to be file.read. And that should read all of the file right here into the variable data. And then we can close the file. When you're done with tools, you put them away. File.close. There's other ways to do this with like what they call context managers. And you'll see things that are like with open as F, and then they kind of come indented like that. You'll see things like this pretty common. It prevents you from having to do this close part and this whole file part as well. File becomes F and all this other stuff. I think it's easy to see what this is doing. So we're going to do that. We're going to open the file. We're going to read the data. We're going to close the file. Then we're going to do something with the data. What do I do with data? I'm going to encrypt it. Let's see what happens when we encrypt file data. All right. Encrypt. What would you like to encrypt? What file exists? I had a secret message.txt. Secret underscore message.txt. Okay. It says I'm encrypting, and then let's zoom in a bit, sorry. It says I'm encrypting, and then I see B, yada, yada. I want to keep the secret, and I see /n/n. Didn't I have all of this stuff, but it was all on multiple lines? Yes, I did. The byte string representation shows you all of the escaped characters. It kind of loses, if you want to call it formatting, it loses the formatting. It shows you that this character has a byte value of that happens to align to the printable character T, right, on the ASCII chart. This happens to align to the printable character I. This happens to align to the printable character that represents a space in your text. /n, there's no way for it to represent without actually rendering that. So that's why you see the escaped characters. So what are we doing? We're actually opened the file that was there, secret message.txt. What happens if I type a file that doesn't exist? Non-existent. Existent? Is that how you spell existent? .txt. I get a file not found error, no such file or directory, non-existent.txt. It tells me where that error occurred on line 10, which makes sense. I tried to open something that doesn't exist. Fair enough. So we can worry about exception handling and defensive programming, defensive coding later on. For right now, that will work well enough. So I've gotten all of these bytes, and again, files are stored on your hard drive as bytes, a sequence of bytes. We got to do something with these bytes. There are libraries that allow us to encrypt in Python really easily, and I think one of them is PyCryptodome. I'm going to go to Google. I'm going to ask Google Python encryption library. There's PyCrypto, there's cryptography, there's more than one. There's not just one, there's several apparently. The one I remember is PyCryptodome for some reason. I'm going to type PyCryptodome. I don't know why I remember it, I just do. So let's see. I'm going to go here. So an almost drop-in replacement for the old PyCrypto library. Ah, interesting. PyCrypto. Ah, I see. When was this updated? This PyCrypto, maybe it's old and it's no longer supported. It looks like, I mean, they're referencing a CVE from 2013. So that's a while ago. Let's, I don't know who or what this is, but apparently people are doing away with it and they're messing with PyCryptodome or PyCryptography. So I'm gonna mess with PyCryptodome, and we're gonna see what this is and how it works. It looks like we can install it with this. So I'm gonna copy. I'm gonna open up my terminal. And I'm going to install this library because it's probably not there. How can I know that it's not there? Let's find out how to use it. Examples. I said we wanted to use AES encryption. Great. Sweet. This looks like encrypt data with AES. That's exactly what I was trying to do. Oh, wow. Wait a second. It looks like we're doing this. Yada, yada. We take the key. We do all this stuff. Hey, man, this is our program right here. All right, so how do we make this more useful to us? Because this is encrypting a single file. How do we use this to encrypt, I guess, any arbitrary file on our computer? Great, I'm gonna open my documentation to the left. And what do? I can try to see if it's already installed. I'm pretty sure it's not. From crypto.cipher. See, I didn't get any suggestions. That's a good indicator that it's not installed. So I'm going to go ahead and install it. Oops. And it actually should be pip 3, as in Python 3. Okay, cool deal. It seems like it's already installed. And then it says import AES. If I save this, if I try to run it and my program doesn't crash, that means that this line of code worked. Oops. What file would you like to encrypt? Hey, that means it got that far. It got to this line, meaning that all of these lines executed kind of successfully, right? So nice. All right. I'm going to go ahead and interrupt it. Doesn't matter. Just give it gibberish. Now it's telling me, what do I need to do? Oops. So the following code generates a new AES 128 key and encrypts a piece of data into a file. We use the EAX mode because it allows the receiver to detect any unauthorized modification. Similarly, we could use any authenticated encryption modes like GCM. I don't know what a lot of those mean. How would I find out? Read about them. Encrypt, then authenticate, then translate. That sounds complicated. I want to use a very simple mode. I think there are other modes, particularly ECB and CBC, that are unauthenticated. You could argue that it's less secure. It's not even much of an argument. It is less secure, but it might be easier to conceptually get your mind wrapped around. So what do we do? In our encryption function, it looks like we have to generate a key. Oh, we also need to get random bytes. So I'm going to copy this line. Oops. This is copy and paste code, y'all. Check this out. Boom. Get random bytes. I need to define the key. And again, remember an encryption algorithm, the algorithm itself can be public knowledge. The thing that is secret is the key. That's what makes it, everything else can be known publicly about it. But if you don't know the key, you shouldn't be able to get access to any of the information. So let's say our key, and I'm going to go call it like secret key is random bytes. We can use a manual key this entire time. So I'm like, it says it needs 16, get random bytes. It's asking for bytes. Remember that thing I said a second ago, way up here, about this B being prefaced before the quote in a string? That's how you define a byte string. So if I type A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, is that 16? Yeah, that's 16. Those 16 characters, that's my static key. It's not a random key. It's not it's as if I've always used that as my password, right? That's what I'm going to define as my key. We'll do that for right now, and then we'll come back later. I'm going to comment that out for the time being. We're going to use this as our password. Actually, let's change it. Rather than secret key, we'll call it password, right? Encrypt, password. All right, so we have to create the cipher. I don't know how to describe this exactly, but like the cipher engine. Okay, so that's the thing that drives the encryption. So cipher engine, and that's totally not a scientific name for it. I just made that up. So cipher engine equals AES dot new, and then what are the different things we can do? We can call this our password. We have to give it based upon this password, and we have to tell it a mode in which AES operates. In case you weren't aware, AES operates in a bunch of different modes. AES operation modes. The difference in 5 modes of the AES encryption algorithm. Okay, so ECB is the oldest, like one-for-one translation. If you see a T, turn it into a W. If you see a J, turn it into an R. Whatever that translation map works out to. It's not just about letters, obviously, it's about numeric values, but electronic code book is the simplest thing. This looks like it would be an interesting resource. If we're interested in learning more about that, we will learn about ECB and CBC in the slides, if you haven't already seen the slides. CBC is better because it doesn't allow for that one-to-one translation. There's a really interesting graphic in the slides that show you why you should always avoid ECB for what they call like a plain text attack or a known plain text attack. CFB, cipher feedback. I don't know what all of these are in a great depth. So yeah, we're just going to stick with CBC and ECB because again, I think those are the two easiest to wrap your head around. Show, what are we doing? Our mode, we're going to tell it that. If we go back to our example code on the documentation website, because again, they're providing you examples of how to use their library. We can put AES, and then there's I guess some sort of attribute of this AES module that defines, let's see, ECB. Is that an option for us? Huh, I guess maybe it says no suggestion. It didn't automatically fill it in. Import AES any mode any. Yeah, I'm going to zoom out and then I'm going to search the documentation for ECB, particularly mode underscore ECB. I totally guessed at that. I saw there's mode EAX, where I saw, well, I guess that's all I really see there. So I'm going to see mode ECB. Does it exist? Classic modes of operation for symmetric block ciphers, ECB mode. Okay. Algorithm mode ECB. The method encrypt and likewise decrypt of an ECB expects data to have a multiple of block size 16 AES. You might need to use the crypto util padding to align the plain text to the right boundary. Oh, interesting. What is this? Data to pad, block size, the block boundary used for padding. Oh, okay, we definitely want to hold on to this. In fact, I'm going to say import crypto dot util dot padding All right, so what I've done here, I said from the crypto.utilities, import the padding module. And then I'm going to use that for creating the padding, right? Because apparently, if we look at the different modes, it requires a certain minimum size. So I couldn't just encrypt the letter A. I have to encrypt A and then some minimum number of values. And I get it's not the letter A, it's the thing, it's the decimal value that represents the letter A, right? So, and that happens to be in decimal, I think it's like 65. So what does it say here? Block, the standard size of an AES block is 128 bits. It can operate 128, 192, or 256. In the text of plain text, if we use CBC mode, we can use this. A padding attack, chosen plain text attack. Interesting. So this actually talks about the offensive side of it as well. So this is a good article. I will take note of that and I'll put it in, I don't know, somewhere in here. Right. So it's saved for reference. Yes. All right, so Boom. So our cipher engine, it seems like this is valid. What do I have to do? If I use this, ECB has an encrypt. Let me go back to the main code. I just went the back button a couple of times. On the main page, I think if you go to examples on the left, it takes you back to this page. I'll refresh it. Boom. Yeah, there we go. So Cipher, there's a new object called Cipher Engine, AES new, given this password. And if I say cipher, or I'll say encrypted data is a result of cipher engine dot, I don't have code completion, that's unfortunate, encrypt, and then am I supposed to feed it data? It looks like I am. This is encrypt and digest data, but I think, let me find API documentation, crypto.cipher AES. So I'm going to go here. API principles. If I scroll around, ARC4, legacy ciphers, symmetric ciphers with classic modes of operation. Okay. ECB should not be used because it's semantically insecure. For one, it exposes correlation between blocks. All right, so we should not be using this, but we could, right? We could follow instructions on maybe the modern modes of operation for AES, and that would be more secure. So what have we done? We've done AES new, given it the key and the mode. And then that object returns, and it should have the method encrypt and likewise decrypt of a cipher object, expects to have data a length, a multiple of the block size. So that's where we got that thing earlier, I guess. So I'm just going to try to throw the data in there and see what happens. Data. It costs nothing. Why not do it? And then rather than printing the decrypted data, like the plain text data, I'm going to try to print encrypted data and see what we can do with that. Boom. Save it. I'm going to go over to my terminal. Oops. And I think I was running that and I scrolled up a lot. Clear the screen. Let's try it again. We'll say Python 3 encrypt.py. Crypto, no module named crypto. Can you believe it? Crypto. Maybe that's why. Okay. Let's try that again now that we fixed our typo. What file would you like to encrypt? I wanted to encrypt secret message.txt. Whoa, it did something and it didn't break. Oh man, we got lucky. We got lucky. What did it say? It said it had to be a multiple of 16. And we said that there were ls, ls tag L secret. It is 64 bytes. 64 bytes is a multiple of 16. Let's fix that. I'm going to open it up in Visual Studio Code. Secret message. If I say fix it, I'm just going to remove one of the extra lines. I'm going to save that. Now, if I look at it, it's 63 bytes. 63 bytes is not a multiple of 64. Let's try to run that program now. What would I like to encrypt? It's secret message.txt. All right, so now we got a different error. It's more often than not going to be the case that we have to pad our data. So I think they mentioned this thing right here, this crypto.util.padding. If I looked over here, it shows kind of basically how to use it. I've already imported it right here, this crypto.util import padding. How do we get this to be padded? So I think this is what I'm going to do. I'm going to create my Cypher engine. Before I try to create the encrypted data, I'm going to push that down a line, and I'm going to say data is equal to data, right? So data is assigned the current value of data. But what if I change data? What if I said padding dot pad, right? And now it's asking for, what does this function ask for? It asks for data to pad. So I'm going to give it data, data. Its block size. Here, its block size needs to be an integer. That's the next parameter. I held my mouse over it for a second and it came up. So these things we're seeing with the colons, those are what they call type hints or type annotations. They're kind of a note to the developer to say, hey, we're expecting you to feed us bytes of information, not strings, not arrays, not lists, not decimals, but a sequence of bytes, one or more bytes. And then block size is supposed to be an int, an integer. It shouldn't be a float. It shouldn't be a string. Python's not going to, it's only going to crash. It's not going to tell you can't do it. I guess that is its way of telling you can't do it. But it will get passed in as that value. So what does it say? Back to this, it said, a Cypher object expects to have a length of multiple of the block size. The block size needs to be 16 bytes for AES. That's what we're using, AES. So the block size needs to be 16. Print before padding data. And then after padding data. Let's open up our terminal. Let's try to run this program real quick. And before we encrypt anything, I'm just going to comment that out and the print. I want to see what the padding is before. I'm going to pad it, and then I want to see what the padding is after. Encrypt. Secret. TXT. Okay. Wow. It did a lot there. This is my before the padding message. You can see it's just everything I typed, but it looks like it added a bunch of stuff. It added all of these extra characters. It looks like some of them happen to be characters that are printable, like these. It's not all random. This /x notation represents hexadecimal. So I'm seeing the hexadecimal representation 19. So that should be 16 plus 9, which is going to be 25. Right? Is that how math works? Not sure. Perhaps. I don't know. And because 25 isn't on the ASCII table, it's not one of the characters that shows up as a space or a symbol or a letter or something. That's why you're seeing /29 or /x0f. Right? That doesn't have a representation. I see that. Is there something here I recognize? I don't recognize a whole lot of not off the top of my head. I don't know what these are, but those are printable. One, I know they're printable because U and M aren't valid hexadecimal characters. So there's that. This pipe symbol is, some value. So is this underscore /XCA. Anyway, we're just looking at stuff now. It doesn't really matter a whole lot. Let's see. Where are we at? What are we doing now? We're after the padding. It showed this. Oh, interesting. Which one? Okay, so we've padded everything. Let's try to encrypt the data and then put that encrypted data on the screen. We don't need to look at the padding anymore, so I'm going to comment those out. Again, it's not going to run those lines because they start with the hashtag. I think this works. I'm going to try it. Now let's just run it first. Let's see. Secret. So this is our encrypted data. Very cool. Okay. Why don't I run it again? I think it's going to be much the same. It shouldn't be random in any way. It should be like very deterministic. We should always get given the same input. That's the point, the definition of a function, right? Given the same input, it's going to yield the same output, like always, like clockwork. We'll always do that. So what do we do? How do we progress from here? We've got encrypted bytes. Okay, let's refactor our code. So not only are we're gonna encrypt data, we have a password that we're always encrypting with. We could ask for this password in here. I'm trying to think of like, how can we modularize our code and make it more useful for a larger array of projects. So I'm going to print the encrypted data. We don't want to print the encrypted data. We actually need to save that to the file because right now this is only encrypted. It's not saved. It's not protected on our computer. We still have secret message in the clear out here. Encrypt. So what if we change this to be file name? File name. I'm going to move my file operations into this function. So I open the file name, I read the data, or I read the file, put that in the variable named data. I have a password now. I create that cipher engine all the same. I can get rid of this line. I don't think it's not adding anything, nor is that. Right, that was just printing, like looking at the padding. Let's see, our encrypted data is still there. Why did I bring file name in here? Because, yes, that's why. I want to open file name again. I closed it. This time I'm going to open it and I'm going to replace the contents with the encrypted data. Check this. All right. So I can say file equals open file name. And this time, rather than reading binary data, I want to write. I said binary data already. I tipped my hand. I meant to say rather than just reading data, I want to write data. But I don't want to write strings. I want to write bytes. So I can WB for bytes or binary data. So there's that. All right. So how do I do this? How do I say file.write. I say file.write what? Encrypted data. Oops, not Unicode era. Encrypted data. And then once you're done with a tool, you put it away, right? File.close. I guess I can leave my print encrypted data on there. Let me do that. I'll leave it. That way we can see that something happened. As I print data, I'm going to show the unencrypted data. Then before I close it, I'm going to show the encrypted data, right? So file name, what would you like to do? you're going to encrypt file name. So check that out. Is that going to work? I think it will. Save. Let me go over to my program. I'm going to write Python 3 encrypt.py. If I hit enter, it should say, what file would you like to encrypt? Secret message.txt, right? It says you are going to encrypt that. That's this line. And then it says encrypt file name. And then it goes through the wormhole, lands up here, opens the file, reads the file, puts the file on the screen. It puts the file on the screen. And then what do we do here? B. This looks like the encrypted data. It's the same encrypted data as up here. We know that because functions are deterministic. There's no randomness in this. Puts it on the screen, it closes, it goes back through the wormhole, lands right here, and there's nothing in it. That's the end of the program. Print end of program. Thank you. So what happened? Let me type ls-tech-la. I'm looking at all the files. I see that secret message is exactly 64 bytes long. You remember a little bit ago, we padded, we like made that change, and it was just accident that we had 64 bytes like that first time. And we made it like 63. Let's see. Now it's 64 bytes again because we did the padding and it had to be a multiple of 16, which is 4 times 16. If I tried to cat it, that's to say put it onto the screen, secret message.txt. Now it's gibberish. That means nothing. You'll notice though, you see this pipe symbol right there. That's something. We see some of these things may not always show up because of like what they call terminal control codes and control characters, but many of them will. I can see this underscore showing up right here. So yeah, that's our encryption program. How do we recover from it? Okay, let's think about that. Oh gosh, I don't know. Let's start by writing a whole new program. Let's write a whole new program. Control new. I'm gonna call it decrypt. Oops. I'm going to save it. Save as decrypt.py. It's likely I'm going to use these same things. Very likely. These same libraries. I'm going to, at very least, use this one. I'm not sure if I'm going to need this one or not because it's already going to be padded the appropriate length if it's been encrypted. So AES, start by asking, what did I always say? I said file name equals input. What file would you like to decrypt? File name. Let's start by running that. Let's just see if that works. This is one way to start any project you need. So Python 3 decrypt. What file would you like to decrypt? I'm going to call it secret message.txt. And that put secret message.txt onto the screen. Excellent. All right, what do I need to do? I need to define a function, define decrypt, and then I'm going to pass in kind of like the same thing we did here, almost exactly that. In fact, I'm going to steal that, copy. It's like the same operation, but in reverse. Rather than encrypting, I'm going to call it decrypt. I'm going to open that file. I'm going to read its contents as binary because we wrote them as binary or as bytes. We're going to read that, put it onto the screen. We're done with that particular tool. So let's put that tool away so that we close our file. what else do we do? What's the next thing we do? We had to establish a password. We're using the same static password. It should be a pretty short walk for you to figure out how would I interactively collect a password from someone, right? And I have to treat it as bytes. That's something important to remember. I'm just going to copy this line for the time being. Why is my copy and paste not working? My right click. I was trying to show you not just use computer shortcuts or keyboard shortcuts that you can only hear and not see. So I'm sure you can hear my mechanical keyboard doing all the things it does. Okay, so I also have to create a cipher engine. Right click. Man, this is not working. Right click, long, and if I hold it down, it will let me do it. Copy. Right click. Paste. All right, there you go. Just know if you see text kind of like go away and come back and just like appear out of magic, I'm probably copying and pasting. Man, all right. So I think I can copy pretty much the entirety of this function. I don't think I had to write a line of like a new line of code so far. The only thing I've changed is like the name of the function, and I'm going to change this from encrypted data to decrypted data because I'm not encrypting, I'm decrypting that data. And then I also have to change it down here. So Will that work? I think it will work. I think it'll work. Print file name. And actually, I don't even know that I'm not going to print the file name, but I'm going to decrypt the file name. So let me up arrow decrypt. What would you like to decrypt? Secret message.txt. It did something. It read, just like our other program, it read in the file first, and then it ran some operation, the decryption operation, and then it printed other data, and then that looks like what's happened there. It says, this is a secret I want to keep secret. If I ls, tag LA, I have my two encryption and decryption programs. I have secret message, which is 64 bytes. Let's see, and if I type cat secret message, sure enough, that's our secret message. Excellent work. So we wrote a program that encrypts and decrypts, given a file name, given the string-based file name. Remember, this function returns a string. So I think we ask questions with the input. And we remember we have to turn it from a string into bytes because that's what this function is asking for. We know that if we hold our mouse over it, or at any rate, the documentation tells us that it's expecting the key to be a sequence of bytes. So there's that. All right, I'm going to stop the video. If you have questions, comments, concerns, do reach out. Thanks.